Hey guys, welcome back to another video. This video is on comparing populations, and this is going to be 8.3, I believe. Yes, 8.3. So your learning intention is to compare populations using measures of center and variation. You'll know you are successful with this when you can find the measures of center and variation of a data set, when you can describe the visual overlap of two data distributions numerically, and when you can determine whether there is a significant difference in the measures of the center of the two data sets. So I've provided you with a lot of vocab, and truthfully, most, if not all of this, should be review. But I know that there is some content that they don't get to in 6th grade, so I pulled some of what we were learning last school year, what you should have learned in 6th grade, and threw that into this lesson to make sure that you understand everything that you should know for this lesson. So, measures of center. If you don't know what that is, that describes the middle of the data set. Okay? Mean is the average of all values. And then you have the median, which is the middle value when the data is in order. Okay, these are going to be important things for you in this lesson. So that's the measures of center. Now we're going to talk about the measures of variation, and you're going to see these terms, measures of center and measures of variation. And as you see in the success criteria, it talks about you being able to find the measures of center and the measures of variation in the data sets. So these are important things for you to make sure that you are keeping these notes with you until you feel comfortable with the different vocab and understand how to just find them on your own. Okay, so when we're talking about the measures of variation, it describes how spread out the data is. So we're going to say spread out. So under the measures of variation, we have a few things. We have the range, which is the difference between the maximum, or the largest, and the minimum, or the smallest values. Okay, so we take the largest number subtracted by the smallest number, and that's how we find the range. Now we're going to talk about quartiles. So quartiles are values that divide a data set into 4 equal parts. Okay, so we're taking this data and we're going to divide it. So 1, 2, 3, 4. Okay, we're going to just divide it into 4 sections. So you have the quartile 1, which is your lower quartile. So we have here, this is going to be your lower quartile. And then you have your quartile 2, which is the median. That's going to be right smack in the middle of everything. And then you're going to have your quartile 3, which is your upper quartile. So within each quartile, so within the first quartile, you'll have, because that's your just a little section of data. So within that, it has its own median. So in this case, the median for the lower half is the first quartile Q is 22. So the median of the upper quartile is the third quartile Q3, and that will be 32 in this example. Okay, so when we're talking about different quartiles, we're talking about taking all that data and splitting it up into 4 equal parts, and then finding those 3 sections. So here we have the lower quartile, the median, and then the third quartile, or the upper quartile. Okay. So then we have interquartile range, which is the difference between Q3, or the upper quartile, and Q1, which is the lower quartile. So as we looked in this picture, we saw that we broke this up into the lower half and the upper half. And within that, we had the median of 22 and the median of 32. So then when we're looking for the interquartile, so interquartile just means within those quartiles. Okay, so we would take the median from quartile 3, which was 32, and we're going to subtract it from the median of quartile 1, which was 22. So 32 minus 22 is 10. So that's how we would find the interquartile range. Our last key term here is called mean absolute deviation. So this is the average distance between each data point and the mean. So I gave you some steps down here on how to find that. So first, you're going to find the mean of the data. So mean is the average. We add it all together, divide by how many numbers there are. Then you're going to find the distance between each data value and the mean. So step 3, you're going to find the sum of the distances in step 2. So you're going to add those distances together. Then you're going to divide the sum in step 3 by the total number of data values. So we'll look at that a little bit more in this lesson. So let's flip this over, and we're going to look at a couple different types of statistics. So this first one is called comparing populations. And it says 2 data sets contain an equal number of values. The double box and whisker plots represent the values in the data sets. So our first assignment here is to compare the data sets using measures of center and variation. So what do I know? I can look at these data sets and I can say, it tells me that both distributions are skewed, and to use the median and the IQR, which is if you see IQR, that stands for interquartile range. Okay, so I have data set A. If I'm finding the median of data set A, I'm going to say that that is 60, the median of data set A. And then the median of data set B is 90, because I'm looking at, we broke this up into quartiles. This is our quartile, this is our quartile 1 or our lower quartile. This is our quartile 3 or our upper quartile, and right smack in the middle is our median. So that's 90, this one's 60. So then our IQR, which is our interquartile range, so we said when we're finding interquartile range, we're going and looking at, okay, where is the median of each quartile? So the median of the upper quartile in data A is 80, and the median of the lower quartile is 30. So I'm going to take 80 minus 30, and I'm going to get 50 for my interquartile range, so the range between the two. For data set B, my median for the upper quartile was 100, and the median for the lower quartile was 80. So I'm going to take 100 minus 80, and I'm going to get 20 for my interquartile range. So what does this tell me? This tells me that data set B has a greater measure of center, because remember, a measure of center is our mean and our median. Okay, so the average is, we're either talking about the average or the middle. We're describing the middle of the data set. So the data set in B has a greater measure of center. How do I know that? Because I'm looking at the median. The median is my measure of center. It is greater than data set A, so it does have a greater measure of center. And data set A has a greater measure of variation, which is what I look at when I'm looking at the interquartile range. And when I subtracted my interquartile range, my quartile medians from each other, I saw that this has a higher interquartile range of 50, whereas the data set B, they were closer together and they only had 20. Okay, so that's what I did, just comparing the data sets using measures of center and variation. My measures of center was my median. My measures of variation was my interquartile range. So I'm just comparing them. What do I see? What do I know? Okay. So then we're going on to the next question. It says, which data set is more likely to contain a value of 95? Okay. So about 25% of the data values in data set A are between 80 and 130. So if I look at 20% between 80 and 130. Okay. And about 50% of the data values in data set B are between 80 and 100. Because that's our biggest area, right? 80 and 100. So knowing what I know there, I know that data set B is more likely to have a value of 95 because we're seeing that more of our data lies here in this range where you would find the 95 versus data set A where we see more of the data lies between the 30 and the 80 range. So which data set is more likely to contain a value that differs from the center by at least 30? So the interquartile range of data set A is 50, and the interquartile range of data for set B is 20, right? We already figured that out in A. So this means it is more common for a value to differ from the center by 30 in data set A than in data set B. So it would be more common that it would differ from the center by 30 here because we know that this is lower, right? So data set A is more likely to contain a value that differs from the center by at least 30 because we have room here in that 50 to differ by 30, right? If we differ by 30 here, we're going into the negatives. Okay, let's look at this last question. Describing visual overlap. So a double dot plot shows two data sets. Express the difference in the measures of variation as a multiple of the measures of center as a multiple of the measures of variation. So here's my dot plots. So we plot for each one that applies to that number. So that's how a dot plot works. So these numbers you're seeing here apply same. That's why they're overlapping each other. So you're seeing that this 30, there's 4, and here there's 2. And here there was 50 had 1, this one has 3. Okay? So both distributions are approximately symmetric. So what symmetric means here is when your data increases and then decreases, or it decreases and then increases again. Okay, so you're either going like a hill or you're going like a valley, but that would make it symmetric, and we're seeing that, right? Because we go up and down and up and down, up and down. So it is symmetric. So use the mean and the MAD, or the mean of absolute deviation, to describe the centers of variation. So that's what we're going to figure out for the center, to describe the centers and to describe the variations. Remember, mean describes the measures of center, MAD describes the measures of variation. So we're going to look at the data sets. So to find the mean, we would add up all of these numbers. So I'm going to go 20 plus 30 plus 30 plus 40 plus 40 plus 50, just keep going. However many there are, add those all up, it came to 810. Then I'm going to count how many were assessed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there was a total of 810, and there was 15 dots. So that's 15 data sets. So we're going to take 810, divide that by 15. Our mean is 54 for data set A. We're going to do the same thing for data set B. We're going to add up all of the amounts here, which gets us to 420. And there was, again, 15 dots on the plot. So we're going to take 420, divide that by 15, and our mean for data set B is 28. Then we're going to find the mean of absolute deviation. So that is going to be, if you remember, let's go back to the front and look at what we have to do here. So you're going to find the mean of the data, which we did already, right? We found our mean let's just look at data set A is 810. Then you're going to find the distance between each value of the mean, and you're going to add those sums up. So I'm going to take the distance between, if this is 800, my mean is 54. So then I'm going to take the distance between each one. So 54 and 20, the distance is 34. 50 and 30, the distance is 24 and 24. I'm going to add all of those distances up together, and then I'm going to get 244. I'm going to divide that by how many numbers there were, and then I'm going to get from my mean absolute deviation is going to be approximately 16. And that's why when you see this equal sign and it's wavy, that's telling you that's approximate. It's not an exact number. Okay, so we just do the difference, and then we're going to take the mean absolute deviation of data set B. So I know that the mean was 28, so then I'm going to come over here and I'm going to go through each point and find out what is the difference between the two. So the mean, if it's 16 and 0, that's 16, 16, 16, 16 and 10 would be 6. 20 and 16 is 4, 4. I'm just going to add all those together, and I'm going to get 236. Then I'm going to divide that by 15, and I'm going to get approximately 16. Okay, so that's the information that I have so far. And then I'm going to take the difference in the means. So I have 54 and 28. Those are my means. So I'm going to find the difference, which is 26. And then I'm going to put that over my mean absolute deviation, which is 16. And divide that, and I'm going to get 1.6. So the difference in the means is about 1.6 times the MAD, or the mean absolute deviation. Okay, so you're going to be trying problems like this on your classwork. I am going to give you multiple sheets because I want to make sure that you understand measures of center and measures of variation. So you're going to do a couple sheets that are going to just focus on these skills that you may have missed in 6th grade, so that you can get really comfortable with this, and then you'll do a couple sheets that have you working on these skills. Okay, so don't think I'm just throwing you in there and you're like, what in the world is all of this? I don't know what I'm doing. So you're going to get a chance to practice your skills on all of these vocab terms first, and then you'll use that in comparing statistics. All right, have a great day.